Hello guys, so in this video we will go over a popular sorting algorithm answer interviews, and that is none other than merge intervals. The goal of this video is to walk through the solution of this problem and code it using Rust. So, um, so the problem, it says given an array of intervals where intervals I is equal to start I and end I, so this will be the starting index and ending index, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all intervals in the input. Okay, fairly simple. Then we go here and it says input intervals is 1, 3, 2, 6, 8, 10, 15, and 18. Now if you carefully look at it, we see 1, 3, and then 2, 6. We know these two are overlapping. It may seem simple to you that, oh yeah, it's overlapping, but how did we exactly figure that out? Well, if you look at the second, if you look at this number, which is 2, and we look at this number, which is 3, we know that 2 comes before 3, therefore it must be overlapping. So with that logic, we can easily just say, okay, well, if your second, if the first index of second element is less than the last element of the previous element is larger, right? So if this is less than or equal to uh, this number, that means they're overlapping. So yeah, that makes sense. But with that logic, when can we run into trouble? Um, so let's put this number behind 8 and 10. Now, if you put behind 8 and 10, we know 8, 10, and 1, 3 are not overlapping, right? But if we follow the logic and logic what we just discussed and say, okay, if this number, sorry, if this number is less than or equal to this number, then it's overlapping, but we know it's not overlapping. So how can we fix this? Well, the simple solution is just sorting it. If we sort it, then we can never, we don't have to do additional checks and make sure that 8 is, any additional check that will require us to check if 8 is less than 1 or anything like that. If we just do this, then we can simply just follow the logic of 1, 3, 3 being greater than 2. That means it's overlapping. Then 6 is less than 8, so not overlapping and not overlapping here, right? And with that logic, we can go ahead and program it. So first step will be sorting. So we can just say sorting. Actually, before we sort, we need to assign our variables or initialize our arrays that we're going to be using. So the first array we're going to be using, or vector I should say, we're going to be using is result, and we're going to mutate this. So we're going to say let mute uh, result equal to vec. We're also going to assign this as mutatable because we're going to be mutating this as well. And we're going to take the ownership away from this variable and assign it to a different named variable. We're just going to say original, just so we have easier time understanding. And then intervals. So once that's done, we also, before we get to the sorting part, we don't want to be sorting if the array is empty. Here it does say that array length is always gonna be greater than 1, but you know what? We'll just go ahead and put the check in. So we'll say if array original dot len is less than or equal to 1. So if there's only one interval, we also don't want to sort it. We can just early stop and return it, right? It doesn't make that big of a difference, but we'll just do it anyways. But yeah, if it's anything like this, we just want you to return the original. We don't want you to do anything else. Original. Okay, so now that's done, we can finally move on to sorting. So for sorting, we're gonna use lambda function because since it is 2, we can't just use simple. Since the elements are also an array, we can't just use simple sort. We need to define our lambda function or the comparator. So we're gonna say original dot sort by, and we're gonna say, okay, you know what, A and B, so that's gonna be the first um, element and the second element, and we're gonna say, okay, compare A of 1, sorry, A of 0, and compare it with CMP um, B of 0. So that's fairly simple. So original sort by, we're gonna take in A and B, so that's this, and we're gonna compare it with the first element and the first element. Yeah, fair enough. Oh, we're also gonna need to pass in a reference. Forgot to say that. So, you know how Rust is. Yeah, so pass in the reference for B, compare with A0. So yeah, that's done with the sorting. So now comes the fun part. Now, after we're done sorting, we're gonna be putting in the logic to compare these two, the first element of the current and the last element of the previous. And we're gonna, depending on what the result of the comparison is, we're gonna merge it or not merge it. And we're gonna push the result into the result vector. So to do that, we're simply, first we're gonna define what the original is. We have to uh, so let mute previous is equal to original 0. So first we have to initiate the previous and assign it to the current or current element. So we're gonna make that the first element, right? Because that's gonna be the first element we're gonna be comparing to original. We're also gonna take the ownership away from it. Oh, what am I doing? So so what we're gonna do is, okay, so previous, which is gonna be always pointing to the previous element, and we're gonna say original 0, so we're going to initiate that with original with the first index in the intervals list, and we're going to take the ownership away, which makes sense because we don't need the element to be owned by original anymore. We're just going to be pushing the previous to result. So fair enough. Now let's iterate through all the current variables. I mean current elements. So current for current in original, simple, right? And we're gonna compare now, and we're gonna say, look, if original 0, so if this is less than or equal to this, it's going to be merging, right? So we're going to say if current 0 is less than or equal to pre previous previous 1. Oh, what did I do? Previous 1. If that's the case, then we're gonna change what previous previous 1 is, right? So now we're gonna say the previous 1 previous 1 is gonna be, so what is previous 1 going to be? So previous 1 is this, right? Now what should this be? Should it be 3 or should it be 6? We want it to be 6, right? Because that's what our, so once we compare and we realize, okay, you know what, we're gonna merge it. So how are we gonna merge it? Starting index is gonna be 1. What's gonna change is this. What is this gonna change to? Well, it's gonna be changed to the maximum of either this or this. Whichever one is max. If these two are overlapping, we want to get the maximum ending index, right? So we're gonna say the previous 1. So this will be std cmp max. We're gonna say previous, right? Because we're gonna be comparing previous 1 with current 1. There you go. So now that's done. So now we have the merged, so the merged elements are stored in previous. So we're gonna say, look, else if it's if our if our if the two elements are not overlapping, we're just gonna simply push the previous into the result. Because since if these two are not overlapping, we just want to push this in the results, which makes sense. And since our two merged results are also stored in previous, this statement will take care of that too. So we're gonna say result.push previous dot to owned. Once again, we need to take ownership away from the previous and assign it to result. And we're gonna define result as the new current, and we will take ownership away from the current as well. Yeah, that's it. So let's just walk through this once again. So first we're just gonna sort it. That's simple. Then we're gonna say, look, compare every element, compare every element to the previous element. If they're overlapping, then reassign, then reassign the period. So reassign the interval of the previous element, right? And that's what we do here. Now, when you find that two elements are not overlapping, push the previous elements into the result and assign the current element to the previous element, and then we can just keep updating that way. So once that's done, we also want to be careful that if the last current is overlapping, then it's just going to exit out of the for loop and it's never going to go here, which means one of the result will not be pushed. So one of the elements will not be pushed into result. So we just want to do the last push result dot push. Oh, I will say previous dot to owned. Just going to say this. And lastly, we're just going to return the result. We're just going to type result and we're done. Lastly, we're just going to hit the run and we're going to see the code. Gonna press run. Oh, what did I do? Mismatch types, result, current, expected struct. Oh, right, because, okay, that was really stupid. But yeah, Rust is, sorry, result is not supposed to be here, it's supposed to be previous, right? Because we're going to be assigning the current to the previous. And then let's run the code now. Perfect. So it's accepted now. It passed it. We're just gonna submit and see what we get. Okay, perfect. Yeah. So it passed all the test cases, and yeah, this is the solution for merge interval in Rust. Also, do keep in mind that with Rust, there's a lot of idioms out there for so for loop you can use match statement and stuff like that. But I just want to keep it simple as possible. So if this is your first time learning Rust, or if this is your first time, then it's easier to compare this with other languages like Java or C++ and see how the two languages are overlapping. But yeah, thank you.